ECG waves, segments, and intervals. In this chapter, we will talk about what elements an ECG consists of, what waves, intervals, segments it contains. Let us examine how each of these elements is formed, why the wave have a different orientation, and for what they are responsible. Consider an example for an ECG. It can be seen from the figure that any ECG consists of some horizontal lines and some elements that are formed of waves. The waves always alternate, now small, then large. They look up and down. If you look closely at this ECG, you can notice the repeatability of some elements. Take one such ECG element and schematically increase it. What does this element consist of? First, you need to say about a straight horizontal line from which various elements move up and move down. This line is called isoline. Isoline is estimated or analyzed according to the TP segment. Looking ahead, for example, to analyze ST segment, we should compare ST segment with TP segment, and according to this we can say there is ST elevation or ST depression according to the TP segment. All elements that go beyond the isoline are called waves. The waves are positive if they are directed upward from the counter, and negative if they are directed downward from the counter. Each wave has its own name. There are 5 main waves: P wave, Q wave, air wave, S wave, and T wave. First of all, let's talk about what I said, the main ones. Why did I say the main ones? Because there is still a 6th wave. It's the U wave. But we will not consider it, since its diagnostic value tends to 0. In addition, there is still much debate about the origin of the U wave. Secondly, why are the waves called P, Q, R, S, and T? The answer to this question is known only to the fathers of the ECG, who invented this method. Therefore, these letters do not carry any meaning and logic at all. These waves are called so because they were once called that. Besides, there are 2 main intervals in the ECG. It's PQ and QT intervals. What is an interval? An interval is a certain wave or several waves along with a piece of the isoline. In other words, it is a wave plus an isoline. Therefore, the PQ interval is the entire P wave and a piece of the isoline before the beginning of the Q wave. In other words, this is the distance from the beginning of the P wave to the beginning of the Q wave. The second most important interval is the QT interval, which is presented as the distance from the beginning of the Q wave to the end of the T wave. That is, it includes the Q wave, R wave, S wave, and a piece of the isoline and the entire T wave. In different textbooks, you can see other intervals and other segments, but we will not consider them since they are mainly of theoretical value and in practice they are rarely used. In the ECG, there is also a QRS complex, which includes 3 waves: Q wave, R wave, and S wave. Why was it joined in the complex? This becomes clear when you notice that the QRS wave are not separated by an isoline. They go into each other and are separated by isolines only from the P and T wave. Beside of all, in the ECG, there are also segments. Segment is a section of the isoline between the waves. There are two main segments. The PQ segment, it is the distance from the end of the P wave to the beginning of the Q wave. And the ST segment. The ST segment is the distance from the end of the S wave to the beginning of the T wave. Now let's consider in more detail each wave, interval and segment, what they consist of and how they are formed. What is the P wave? Let's return to the first chapter or for the video of the conduction system of the heart and recall that the excitation starts in the sinoatrial node and is immediately transmitted to the right atrium, exciting it. The green circles on the figure below represent the excitation of the right atrium. Graphically, this can be represented as a kind of excitation wave. It is shown in the figure as a black wave, which has its own peak. Own peak, in other words, is the maximum height. This is the excitement of the right atrium. Further, from the right atrium, an excitation pulse is transmitted through the interatrial bundle to the left atrium and also excites it. In the figure, these are the blue circles. Graphically, this can be represented by the second wave, the blue wave, which also has its own peak. In other words, maximum height. This is the excitement of the left atrium. Pay attention to the figure below. The excitation of the right atrium has not yet ended, and the excitation of the left atrium has already begun. The black and the blue waves intersect. This is the intersection of the black wave and the blue wave. On the electrocardiogram, these excitations are combined into one wave. The wave is green in the figure, and it's visible as the P wave. This means that the P wave consists of two parts, two halves. First half of the P wave is the excitation of the right atrium. It is the ascending part of the P wave. The ascending part represents the excitation of the right atrium. And half of the wave, the second half, is the excitation of the left atrium. It is the descending part of the P wave. This means that the descending part of the P wave is the excitation of the left atrium. So like that, the P wave is formed. What is the PQ interval? Again, we return to the first chapter, to the video of the conduction system of the heart, and recall that in addition to the fact that the excitation was transmitted to the left atrium, the excitation along the interstitial paths is transmitted also to the atrioventricular node, to the AV node. The PQ interval is the P wave, the excitation of the two atria, and a piece of the isoline before the beginning of the Q wave. Remember the number at the end of the first chapter, 008 seconds. This is the time for which the pulse is delayed, is slow-upped, is kept in the AV node, while in this time the excitation of the surrounding myocardium does not occur. Because of that, on the ECG, after the P wave, we see a direct isoline. Because in this time no excitation occurs, in this time the impulse is slow-upped, is kept, is delayed in the AV node. Because of that, we see a direct isoline. So, to summarize, the PQ interval includes the excitation of the two atria, this means the P wave, and the time it takes for the excitation to pass through the AV node until the ventricles are excited. What is the QRS complex? We can already understand that the QRS complex will reflect ventricular excitation. From the AV node, the excitation is further transmitted along the His bundle. Let's show in the figure a recording electrode. Why is the recording electrode shown in the figure? This is necessary to understand why one wave has an upward direction and another have an downward direction. If the excitation vector is directed from the recording electrode, then on the ECG a negative wave is recorded. And if the excitation vector is directed toward the recording electrode, then on the ECG a positive wave is registered. However, it is important not to miss one point. We recall and say that the bundle of His is located in the interventricular septum. So, when an impulse passes through the bundle of His, it does not immediately excite the interventricular septum, but only at the end of its path begins to excite the myocardium. Because of that, for the excitation of the interventricular septum, the excitation needs to turn in the opposite direction. The excitation factor of the interventricular septum is directed in the opposite direction. In this case, it is the Q wave, which is directed downward and shows the excitation of the interventricular septum. After that, the apex of the heart is excited and its vector is directed toward the recording electrode. At this point, the ECG records a positive R wave. After that, the base of the heart is excited. The vector is directed from the recording electrode. On the ECG, a negative S wave is recorded. Thus, we can figure out that the Q, R, and S waves are a graphical display of the excitation of various parts of the ventricles of the heart. Now, let's talk about what is the ST segment and what is the T wave. After the excitation of the ventricles has passed, they need to restore their potential to the original level. This means that the restoration should occur. The scientific term of excitation is called depolarization, and the scientific term of the restoration to the initial level is called repolarization. Remember, depolarization is the excitation and repolarization is the restoration to the initial level. This means that after depolarization, a smooth transition to the repolarization occurs. These two processes are superimposed on top of each other. This means that there is still excitement, but recovery is already beginning to the original level. And when their total work will be equal to zero, an isoline in the form of the ST segment will be recorded on the ECG. But the T wave is already through repolarization of ventricles. In the myocardium, the process of repolarization over depolarization began to significantly prevail. Now let's talk about the duration of the waves, intervals, and segments. In the ECG, it is very important to be able to not only analyze the shape and characteristics of the waves, intervals, and segments, but also analyze their duration. This is very important because changing them over time will often carry a definite diagnosis. So remember, P wave and QRS complex are equal to 0.1 seconds, and the PQ segment is equal to 0.08 seconds, and the PQ interval includes the duration of the P wave plus the duration of the segment PQ. This means that PQ interval is 0.18 seconds. It includes the duration of the P wave, 0.1 second, and plus the duration of the PQ segment, 0.08 seconds. And the QT interval is 0.35 until 0.44 seconds.